In fluid mechanics, this equation is used many times. As engineers, we want to ask the question, why should I believe this? Or another way is, where does this equation come from? I claim that this equation comes from Newton's law of universal gravitation. And in the process of deriving this equation, the constant g is revealed to be 9.81 meters per second squared in SI units and 32.2 feet per second squared in English units. Here are the reasons why I make that claim. Number one, Newton's law of gravity applies to any two bodies, therefore it must apply to Earth plus any other body. So I identify a mass m as body 2 and the Earth as body 1. Next, I claim that in Newton's law, the terms identified below are constant, and we can group these terms and let this equal a new constant, which will give the symbol the lowercase g. The gravitational constant, capital G, is certainly constant. The mass of the Earth would be certainly constant. Now, this is actually the distance from the center of mass of the Earth to the center of mass of any other body. And I'm going to next argue that this is approximately constant. Now, the distance that needs to go in Newton's law of universal gravitation is right here. And so that's equal to the radius of the Earth, this distance, plus the distance from the Earth's surface to the height at where the body is located. Let's call that height h. And the argument goes like this. The radius of the Earth plus h, when I take that and square it, for any small value of h, say less than 10,000 meters, or 40,000 feet, within about 0.3%, this will equal the radius of the Earth squared. And the reason is that this number is on the order of 6.4 million meters. 6.4 million meters. So when you add a number like 10,000 to this and square it, it's just as if you could neglect this height. So the right-hand side of the equation becomes the mass of the body on Earth times this constant g, and then I'm going to define the weight W as a gravitational force on a body of mass m near the Earth. The final result is right here. To figure out the numerical value of this constant g, look up the accepted value, or you can calculate this using the mass of the Earth, the radius of the Earth, and the gravitational constant g. QED is Latin, and it means basically it is shown or it is proven. Note, when we use this equation, the term g that appears in the equation should be thought of as a constant, given by the gravitational constant, the mass of the Earth, the radius of the Earth, squared. Using Newton's second law of motion, sum of forces equals mass times acceleration, one can also show that this constant will be equal to the acceleration of a falling body when the only force acting on the body is the gravity force. Thus, it is common to label the constant g as gravitational acceleration. But this idea really comes from a different law of physics. And so when I'm using W equals mg, I'm thinking of this as a constant given by these terms here. Now, as always, I recommend figure out the physics of all important equations. So for the equation W equals mg, here's one way to describe the physics. The weight of a body on Earth is exactly given by the product of the mass of the body times the constant g. That's it. Hope you've enjoyed this video.